All right, so number 1a, x squared times x to the 6th. You add the 2 and the 6, you get x to the 8. Part B, 6x cubed times 4x squared times x. The 6 and the 4 make 24. The x to the 3rd, x squared, and x to the 1 add up to be x to the 6. Part C, the 3 and the 5 multiply to 15. X to the 0 multiplies to nothing. Y to the 5th and the y squared, the 2 and the 5 make y to the 7th. The x to the 0, I wouldn't even write that because it's just equal to 1. So you end up with 15y to the 7th. Problem number 2, part A. Remember, we are trying to cancel things out. So on top, I have 5 x's. On the bottom, I have 8. So when I cancel them out, I'm left over with 3 on the bottom. On part B, I've got x to the 5th over x cubed. Well, that x to the negative 3 moves up, and now I have x to the 3rd on top. But I already have x to the 5th on top, so now I have x to the 8th on the top. My y's, I have y to the 7th on top, y to the 10th on the bottom, so when they cancel, I'm left with y to the 3rd on the bottom. Part C, 6 over 18 reduces to 1 over 3. My x to the negative 2, I can move to the bottom and combine with that x to the 3rd, and that becomes x to the 5th. And the y to the negative 1 can move to the top, and I end up with y to the 12th on top when I combine it with my other y. Number 3, power of expressions with exponents. Remember, you multiply the exponents. When an exponent gets exponented, that becomes x to the 15th. This 3 is going to go to that x, but it's also going to go to the 2. So I'm going to get 2 cubed, and then x, 4 times 3 is 12. And I know that 2 cubed is 8. So I'm going to rewrite that as 8x to the 12th. Part C, this 2 gets distributed to everything. So I get 5 squared, x to the negative 2, y squared, z to the 10th. The 5 squared is 25. The x to the negative 2, I move to the bottom and make it a positive. My y squared and z to the 10th stay right where they are, on top. Okay, the next problem, multiplying expressions. These ones, same as before, but now you're just having to add fractions. So 3/7 plus 2/7 is 5/7. So my answer is x to the 5 over 7. On this one, I'm going to add 3/5 and 1/2, but I need a common denominator, which is going to be 10. So on the left, this multiplies by 2. On the right, I have to multiply by 5. So I end up with 6/10 plus 5/10, which becomes x to the 11/10, because 6 plus 5 is 11. Part C, the 5 and the 6 just multiply to be 30. The x to the 1/2 and the 2/9, I have to do 1/2 plus 2/9. So a common denominator is going to be 18 on both sides. So this side I times by 9. This side I times by 2. So I need to do 9/18 plus 4/18, which is 13/18. So x to the 13/18. Next problems. Same as we did before. We multiply exponents with other exponents. Remember, when you multiply fractions, you multiply straight across. So this would become 3/8. So I'd have x to the 3 over 8. This one, that 3/2 gets applied to everything. So I end up with x to the 15 over 2 because I times the 5 and the 3. And my y's, I multiply the tops and get 12. I multiply the bottoms and get 18. So this one, we might want to simplify the 12 over 18 a little bit. So x to the 15 over 2, and then that y could reduce by what, 2, and become 6 over 9. And that looks good to me. Third one, same thing. The 1/2 goes to everything. Well, the 9 technically has a 1 there, and 1 times 1/2 is just 9 to the 1/2. X to the 6th becomes x to the 3rd, because you take 6 times 1/2, and my y becomes y to the 4 over 6. And if I simplify this, 9 to the 1/2 is actually just the square root of 9. So that's 3 x to the third, and y to the 2/3 would be my final answer. Last ones on this page, convert to rational exponents. That means I need exponents with fractions in them of some sort. So remember, I take that number in my index and I put it on the bottom of my exponent. So this becomes x to the 3/4. On part B, there's a 2 right here that you don't see, and there's a 1 right there that you don't see. So that ends up becoming x to the 1/2. And there's a big 5 out in front that's being multiplied. Part C, again, that 8's just out in front. The 5 goes to the bottom of each exponent. So I get x to the 3/5. And y technically has a 1, so it becomes y to the 1/5. All right, back page. We want to convert to radical, which is easy. I just take the bottom number of my fractions in my exponent and I put it in my index. So that becomes the 5th root of x to the 4th. Part B, both of these have a 5 on the bottom. So they both are going to go underneath. The x is going to have a power of 4, and the y could have a power of 1, or you could have just left it as a y. Same thing. 11x to the half. Be careful because the 11 is in front by itself. The half is only with the x. So I'm going to end up with a little 2 here and a 1 there, which can be rewritten just as that's just the square root of x, right? That 2 and that 1 you don't have to put in the problem. Simplifying square roots. Remember, this is just where you break it down. Square root of 49, if you didn't already know that was 7, you're looking for groups of 2, and there's 2 7s, so it comes out, and your answer is 7. On this one, 72 is what? 2 and 36. 36 is 2 and 18. 18 is 2 and 9. 9 is 3 and 3. So when I rewrite this one, I'm going to write it as 2 square root 1, 2, 3 2's, 2 times 2 times 2, and then 2 3's right there. Now, there's no number right here, but I know when there's not a number there, I pretend it's a 2. So I'm looking for groups of 2, and there's one, and there's another one. Those pull out, and that group of 2 becomes just a regular 2. And I already have a 2 in front, and I'm also pulling out a 3 in front, and I've got a 2 left over on the inside. So when I rewrite this one, I'm going to end up 2 times 2 is 4 times 3 is 12 root 2. Okay, 8 root 99. 99 is just 11 times 9. 9 is 3 times 3. So when I rewrite this one, I get 8 root 11 times 3 times 3. And I'm looking for groups of 2 again. So that 3 pulls out, and I get 3 times 8 root 11, which is 24 root 11, would be my final answer. Okay, a couple more. Simplifying square roots when there's just expressions, or variables, sorry. So again, we're assuming there's a 2 there, and I'm looking for groups of 2. When I look at my x's, I'm going to have 3 groups of 2 because I have 6 x's on the inside. Remember, that's like having x times x times x times x times x times x. So I'm going to have 3 groups of x's that come out. So I'm going to end up with x to the 3rd as my answer. Part B, x to the 9th. I'm still looking for groups of 2, and I'm going to get 4 of those groups because 9 divided by 2, I can't go evenly. It actually, 8 of them get pulled out, but I'm left over with 1 x on the inside. Part C, my x's, I can make 2 groups of x's that come out, and my y's, I can make 1 group, but I'm left over with 1 y on the inside. Now, if I mix numbers and variables together, the square root of 49, that's still just 7. Hopefully you know that one. So I'm going to have a 7 move out, and x to the 6, that's 6 or 4. That's 6 x's, right? 3, 4, 5, 6. And that makes 3 groups that are going to come out. So my answer is going to be 7x cubed. Part B, my 50 breaks up into, let's do 5 times 10, which is 5 times 2. So when I rewrite this one, I get 5 root 2 times 5 times 5 x to the 11th. So I'm going to pull out groups of 2. So that 5 comes out, and I times it by this 5 right here. So I end up with a 25 in front. My 2 is still stuck on the inside, but I've got these x's. if I'm getting groups of 2, I'm going to end up with 5 groups of x's and 1 left over on the inside. So my final answer, 25 x to the 5th root 2x. Part C, 44, that's 4 times 11. 4 is 2 times 2. So this one rewrites to be 3x to the 5th square root 2 times 2 times 11x squared. So I'm looking for groups of 2. So the 2 is going to pull out and times by this 3, and I'm going to end up with 6. These x's, I'm going to get one group of x's that comes out, and it combines with these 5 x's. So I end up with 6 x's, and I'm left over with an 11 on the inside. Okay, moving on. We have 10 cube roots of 27. So this time, 27 is just 3 times 9. 9 is 3 times 3. So I rewrite this 10 cube roots of 3 times 3 times 3. I'm looking for groups of 3. Well, there's one. That comes out, and I end up with 3 times 10 in front, which is just 30. Part B, I'm looking for groups of 4. Let's see, 4 times 12. This is 2 times 2. 12 is 2 times 6. 6 is 2 times 3. So this becomes 9 fourth roots of 1, 2, 3, 4 2s and a 3. So my answer, I'm looking for groups of 4. So there's a group of 4 I can pull out. So I end up with 2 times 9 fourth roots, and I've got a 3 stuck underneath. So 18 fourth roots of 3. Okay, part C, 6 cube roots of 7,000. So 7,000 is going to, let's break 7,000 down into, let's do 7 times 1,000, which is just 10 times 100, which is just 2 times 5, and 100 is 10 times 10, which is 2 times 5, and 2 times 5. So this one has a lot of factors that I need to rewrite. So 6 cube roots of, I've got a 7, and I've got 1, 2, 3 2s, and 1, 2, 3 5s, and I'm looking for groups of 3. So I can pull out my 2s and my 5s, and I end up with 2 times 5 times 6 in front, cube roots of 7. 2 times 5 is 10, times 6 is 60, cube roots of 7 would be my final answer. All right, 6 more. Simplifying higher index radicals. So this has variables in it. I'm looking for groups of 9. Whoops, covered up the 9. I'm looking for groups of 9. When I have 18, that means I'm going to end up with 2 groups of 9 that I get to pull out. And so that's 2 groups of x's. So my answer is just x squared. If I'm looking for groups of 5, x's, I'm going to end up with 3 of those, and I'm going to have 2 left over. And y's, I'm going to end up with 5 groups, or nope, I'm looking for groups of 5. So I'm going to end up with 2 groups of 5 and none left over. And don't forget that little 5 goes right there. So that makes sure that's x cubed, y squared, and then it's the 5th root of x squared. Make sure that 2 and that 5 don't look like they're the number 25. Part C, I'm looking for groups of 3. So if I have 20 x's, I can get 6 groups out. And I already have 5 groups in front. And when I take out those 6 groups, I'm going to have 2 left over, right? And then y's, if I take out groups of 3, I'm going to end up with 4 groups of y's and 1 left over. So when I combine this, x to the 11th, y to the 4th, and then I've got cube root x squared y. Okay, last section. Now we mix those two things together. Cube root, 8 is 2 times 4, which is 2 times 2. So this just becomes the cube root of 2 times 2 times 2 times x times x times x. I'm looking for groups of 3. So I'm going to get a 2 and an x that pull out, and my answer becomes 2x. Part B, I'm looking for groups of 3. So 250, I'm going to break that down into 2 and 125. 125 is 5 and 25. 25 is 5 and 5. So that's going to rewrite as 8, 8x squared in front, cube root of 2 times 5 times 5 times 5, right? 1, 2, 3 5s and a 2, and then x to the 6th power. So I'm looking for groups of 3. So I can pull out a 5, and that's going to move to the front and get times by the 8. And my x's, I can get 2 groups of 3. So I'm going to pull out 2 groups of x's, and I've got to combine that with my x's that are already out front. And what's left over? Just a 2. So my answer becomes 40 x to the 4th cube roots of 2. That would be my final answer. Okay, last question on the review. The cube root of 8x to the 30. Oh, this is nice because this is just 2 times 4, which is 2 times 2. And x to the 30, so this just becomes the cube root of 2 times 2 times 2, x to the 30. That's in that parenthesis. This one, 5th root, 32 is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So that one gets rewritten as the 5th root of 2 times 2 times 2 times 2 times 2, x to the 30. So I'm looking for groups of 3. There's a 2. And x to the 30, that gives me 10 groups of 3. In my second parenthesis, I've got groups of 5. So I get to pull out a 2. And I've got 6 groups of x's because I'm looking for groups of 5. So now my 2's multiply to be 4. And my x to the 10th and x to the 6th become x to the 16th. That's a good question. I like that one. Probably a good one to practice for the test. Make sure you understand how to do that.